Hello everyone and welcome back. Today we're going to be doing our last set of notes in this unit, which is all about writing exponential functions if we're given 2 points. So if we're given 2 points on the graph or 2 points of the function, how can I write the equation for the function? So as always, make sure you put the date, and then here's the title of the notes. So what we're going to do is we are going to write down the steps. How do we solve these? And then we're going to do 2 examples. Okay, so the first thing that we're going to say is that if I'm given 2 xy coordinate points, right? So I'm given 2 points. That means I can find the exponential function. Or equation in the form of my exponential graph, which is a times b to the x. Remember that x always has to be up in the exponent. Okay, so what we're going to do is we're going to write down the steps on how do we solve these, and then we'll do our examples. So let's scroll down here a little bit so I can fit all my steps. Okay, so step 1, first thing that you have to do is you have to plug in both of your points, so both of your xy points, into the equation. And what equation are we using? We're using exponential equation, so it's a times b, again, to the x. So I'm going to plug in my x value up here in the exponent. I'm going to plug in my y value over here on the other side of the equal sign, and we will not know a or b. That's what we will be trying to find. Okay, what we're going to do is we're going to stack the equations. Stack the equations, aka division, right? And then we're going to simplify the fractions. So again, we'll go through what all of these steps mean. Okay, once the fractions are simplified, you may still have to cross multiply. So put cross multiply and solve if necessary. Sometimes it's not always necessary that you need to cross multiply. Sometimes you can just solve. But if it is necessary to cross multiply, then we have to do that. And I should say maybe solve, wow, spelling is hard, for, all right, solve for b. Once you have the value of b, you're going to plug b back into one of the equations, one of the original equations, to solve for a. And then step 5 is going to be write the equation. So now you have a and b. So then your last step would be to actually write the equation. Oops. Right, and the equation will be in that y equals a times b to the x format. So those are our 5 steps on how we solve for the equation, right? How do we find the equation? So we're going to look at 2 different problems. We're going to do the first one, will just be normal, and then the second one will be a word problem, and then we'll be done. So if you need a pause to keep writing this, please do so. Otherwise, we're going to move on. So here's our first example. Okay, so example is find the equation of the exponential function that goes through. And our 2 points are 1, 3 and 2, 4.5. So those are the 2 points that my equation goes through. Okay. Okay, so step 1, I'm going to write it out, right? Step 1 said to plug in both the points into this equation, y is equal to a times b to the x, right? So I'm going to plug in both points. Here's the xy. So that gets me 3 equals a times b to the 1. And then here's my xy on the second point. So that will get me 4.5 equals a times b squared. So all I've done is taken my y and my x values and plugged them in for both points. Step 2 says to stack these. Now, I always like to stack it with whatever exponent is biggest on top, but it doesn't matter. So I'm going to do 4.5 equals a times b to the third over 3 equals a time, oh, sorry, this is not to the third, this is squared. Squared over a times b to the 1. Now, if you did it the other way, if you did this 3 equals a times b to the 1 on top, you'll get the same answer. It doesn't matter. But I just personally like to do whatever exponent is biggest on top. Okay, and then I need to simplify this, right? So I guess that's step 3, isn't it? So let's do step 3. 4.5 divided by 3 is 1.5. My a's here can cancel. And then b squared over b to the 1. Let's think. I have 2 b's on top, 1 on bottom. So 1 cancels, right? And I'm just left with 1 on top. So that'll be b to the 1. Well, b to the 1 is just b. So 1.5 equals b. So that's kind of step 3 and 4, right? Or I guess step 4 is finding a. Never mind. Okay, so now let's do step 4. Now that I know what b is, I'm going to take my value for b and I'm going to plug it into one of these two. Doesn't matter which one. I'm going to do this one because it's just b to the 1. So that gets me 3 equals a times 1.5 to the 1. Well, 1.5 to the 1 is just 1.5. So a times 1.5. I'm going to divide both sides by 1.5. And I get a is equal to 3 divided by 1.5 is 2. So a is 2. And then the last step, step 5, is just writing down the answer. So y is equal to a is 2, b is 1.5 to the x. And that is the equation of the graph. Okay, this graph, right, goes through these 2 points, but that's the equation that we're looking at. So hopefully that makes sense. We're just treating this as a fraction, right? 4.5 divided by 3 was 1.5. The a's get to cancel because a over a is 1. And then b squared over b is just b to the 1. and then I was able to solve. So hopefully that makes sense. If not, just make sure that you reach out and let me know. We'll do more examples. We're going to do one more example here, and it is going to be a word problem. So I'm going to write it out, and then we can look at it. Okay, so here is our second example. If you need to pause the video to write it down again, please do so. It says a petri dish of bacteria is growing exponentially. On the second day, there was 12 bacteria, and on the fifth day, there was 96. How many bacteria will there be on day 20? So since I know it's growing exponentially, I know that I'm going to have to use that equation of A times B to the x. Okay. I also need to take the information that I'm given and write these as points, right? So I know that on the second day, there was 12 bacteria. And on the fifth day, there was 96. So that's how I get those points that I can then plug in. So y is 12. I have a times b squared. And then here y is 96. And I have a times b to the fifth. So I have those equations, right? That's step one, if we're keeping track. Okay, and then step two, I want to stack these and simplify it. So b to the fifth is my higher exponent, so I'm going to put that on top. So a times b to the fifth divided by 12 equals a times b squared. And I'm going to simplify this. I guess that's step three. Just running out of room. There we go. Step three is I'm going to simplify. 96 divided by 12 is 8. The a's cancel. And then b to the fifth, again, I have 5 on top, 2 on the bottom. So I cancel, and I'm left with 3 on the top. So I'm left with b to the third. Now I'm trying to solve for b, so I need to take the cube root, right? The cube root of both sides. The cube root of 8 is 2, right? 2 times 2 times 2 is 8. So I get 2 equals b. Awesome. So now I can go step 4, which is plugging it back in. I'm going to plug it back in for the one with the smaller numbers. But again, it doesn't matter. So I have 12 equals a times b now is 2 squared. So I have 12 equals a times 4. So 3 equals a. So then step 5 is I can write the equation. Y is equal to 3 times 2 to the x. So now I have the equation. That's great. So now I can figure out how many bacteria there will be on any day. But specifically in this problem, it wants to know how many bacteria there will be on day 20. So I'm going to plug in 20 for x. So y is equal to 3 times 2 to the 20th. And I simplify this down. 2 to the 20th, it's a big number, times 3 is an even bigger number. And I get, there will be 3, 1, 4, 5, 7, 2, 8. So 3,145,728 bacteria on day 20. So there's my answer. And again, because it's a word problem, I had to answer it in a sentence. And so for these, you guys, obviously there's a difference between math world and real world, right? Like in the real world, probably some of this bacteria will die before day 20. It probably will not be this exact amount. But by using this equation, by using this mathematical model, we can predict a general range of what it will look like. While this will not be the exact number, right, in the real world, in math world, this gives us an idea of how many bacteria there will be. That's it for now. And then if you guys have any questions on writing the equation of an exponential function, just reach out and let me know. Otherwise, we'll see you later.